Okay, thanks. So this is joint work with Melissa Tatari, who is usually here, but for some reason is not here today. There's a large literature in public and labor economics on the optimal design of transfer programs. This is a distinguished tradition that many people are engaged in, and a key input into it is understanding how transfer programs distort the behavior of individuals. Most transfer programs phase in and phase out, and those phase-in ranges of programs have different effects than the phase-out regions. And there's debate in the literature about how to design programs depending upon how much people respond to the intensive and extensive margins. So an extensive margin response is the decision of whether to work at all. An intensive margin response, depending upon which literature you're looking in, could be a decision of how much to work, either measured by hours or earnings. Going back at least to a paper by Peter Diamond, some people have just assumed that people only respond in the extensive margin because they believe that the intensive margin responses are highly constrained. But if you think about it, measuring the nature of intensive margin responses to a policy reform is a very difficult problem. It requires that you understand the joint distribution of potential choices that might be made under two different regimes. Many recent papers in the public economics literature have pointed to two sources of evidence that intensive margin responses are extremely small. One comes from a literature studying EITC reforms. They find that mean impacts on hours conditional on working and earnings conditional on working are essentially zero. A problem with that is that their economic theory tells us that there should be heterogeneous responses to these sorts of reforms. There's a phase-in region, which is going to induce people to work more. There's a phase-out region, which will induce them to work less. And those two effects could cancel out. There's also a bunch of problems with selection. Another literature that's gained a lot of attention in the last couple years looks at bunching at kink points. So if you have a nonlinear tax and transfer schedule, if you have smoothly distributed preferences, then you can show that that a non-parametric prediction of optimization, at least unconstrained optimizations, that there ought to be bunching at kink points, and that ought to be proportional to first order to measure, if you have quasi-linear preferences, to a measure of the intensive margin elasticity. And people have found that there is not bunching in many places where there should be, and they've concluded that maybe intensive margin elasticities are small. I'm going to consider this, and there's many possible critiques of that argument as well, including that people might not truly be unconstrained. So I'm going to think about this more generally and ask, how could, if we have some hypothetical reform that is experimentally applied, how could we figure out what sorts of intensive margin responses are present? And everybody in this room knows that understanding the joint distribution of potential outcomes, even in an experimental setting, is very difficult. There are well-known bounds on the joint distribution of potential outcomes given the marginals. Jim Heckman has a famous paper exploring what you can get out of these bounds in an applied setting. In your prototypical tax or transfer reform, you have something like this. We're going to have, you can imagine that, so we've got our marginal distributions under policy regime A and our marginal distributions under policy regime B. We identify from, if we have a perfect experiment, we can identify both marginal distributions, but what is the mapping between those distributions? In other words, we see effectively the net flows that lead to a new distribution, but we don't understand the gross flows that generated them. So in this example, we've got that people who would have earned a lot, the x-axis here should be earnings. People who would have earned a lot might be induced, some of them might be induced to reduce their earnings. People who would have not worked at all, this is the mass point at zero here, is people who don't work, are being pushed into multiple destination states of working positive amounts. And we don't know how many people are pushed in each way. What I'm going to do in this paper is try to see whether we can just use basic restrictions from consumer theory to rule some of these transitions out. These are going to be basic revealed preference restrictions, and then we're going to use that to get bounds on the size of these sorts of adjustments and see whether people in fact respond along both the intensive and extensive margins. To do that, I'm going to study randomized welfare reform experiment that's gotten a fair amount of attention in the literature lately. It's from Connecticut's Jobs First welfare reform program. It is interesting because it had very strong financial incentives, including incentives that create what's called an eligibility notch in the budget set. So if you earned $1 more than the federal poverty line, you were suddenly ineligible for welfare benefits and you lost your entire grant amount. Okay, so that creates very strong negative labor supply incentives to reduce your earnings slightly in order to qualify for benefits. Bittler, Gelbeck, and Hoynes have a paper in the AER that shows that this reform, even though it had a mean effect near 0, and in fact the final report of this program initially said that it didn't have very big effects, they estimate quantile treatment effects, and what they find is that the effect of this program was heterogeneous, and had strong heterogeneous effects that average out to 0. So there's no effect at these bottom quantiles because most of these people don't work under either state of the world, and so their earnings are 0. Around here, you're seeing that the middle quantiles are boosted, but the top quantiles actually have negative earnings impacts, okay? And so they interpret these negative impacts up here as signs of a negative intensive margin labor supply response. But that's just qualitative, and of course, we all know that quantile treatment effects just give you the impact on the distribution. They don't give you the distribution of impacts. So what I'm going to do in this paper is try to learn something about the distribution of impacts. I'm going to revisit this Jobs First experiment. I'm going to build a non-parametric model of labor supply and program participation. I'm going to augment it with assumptions that allow for earnings constraints and underreporting behavior. And then I'm going to use simple revealed preference arguments similar to those in a recent paper by Chuck Mansky that's, I think, just came out in Quantitative Economics. And we're going to exploit those restrictions to derive bounds on the probability of responding along various margins. And I'll explain more precisely what the margins are that I'm interested in. The bottom line results of the exercise are that we find substantial intensive and extensive margin responses to the Jobs First reform, and that underreporting behavior is important for understanding the effects of this experiment. Okay, so quick background on Jobs First and on welfare reform in general. In 96, US had a major reform. We replaced our old system, AFDC, Aid to Families with Dependent Children, with TANF, Temporary Assistance to Needy Families. It had 3 major components: time limits, work requirements, and improved financial incentives to work. Connecticut enacted its own version of TANF, which is called Jobs First, and they got a waiver to conduct a randomized evaluation of this reform. And so what they did was they took 4,800 single parents that were applicants to the old AFDC program, and they randomized them half-half into a treatment group, which is using the new Jobs First rules, and the control group, which used the prior AFDC rules. We're going to have data from a baseline survey and administrative data on quarterly earnings and welfare participation before and after random assignment, okay? Welfare reform is a multidimensional treatment. I'm not going to get into the details, and I only have 40 minutes today, so I'm going to give you the abridged version of this talk. So the main thing that I want you to think about is this is a stripped down budget set. In the paper, we talk about putting on food stamps, EITC, lots of other stuff. But let's just think about the pure welfare transfers themselves to keep things simple. Okay, so on the x-axis here, I have earnings. On the y-axis, I have your disposable income, which is earnings plus your welfare transfer amount. Okay, the 45-degree line is what you get if you don't participate in welfare. If you worked under, if you participated under the old regime, AFDC, and you didn't work, you got this base grant amount G, and then there's a kinked budget set, so that implicit tax on your earnings kicks in after some fixed disregard amount, and you have a tax rate of approximately 70% on your earnings up to this range at which you've phased out the total grant amount smoothly, and you're back on the 45-degree line. Under Jobs First, things are dramatically different. You have no implicit tax on your grant amount up to this notch at the federal poverty line. You earn $1 too much, you're off, okay? Obviously, if I don't have any extra stuff, if I don't have any constraints, I don't have any welfare stigma or anything, then this is a dominated region right here, meaning you don't want to work off welfare slightly above the federal poverty line because you could reduce your effort and get paid more. Okay? And so in very stripped down models, nobody would ever locate here, and lots of people should be located exactly at this notch. Okay? So this is what's sometimes called the opt-in effect to welfare. Orley Ashenfelter has a famous classic paper looking at this in negative income tax experiments. So the opt-in idea is that you've made things very generous right here with this kind of cliff in the transfer scheme, and so people who would have not participated in welfare otherwise will suddenly decide to reduce their effort and participate in welfare. So it's incentivizing some people to work more by reducing their implicit tax rate on their earnings, but it's also offering this notch which could cause people who would have not been on welfare at all to suddenly join welfare. So there's positive and negative labor supply effects. There are also non-financial incentives. One is a time limit. I'm going to ignore that today. We do some tests for anticipatory behavior. We don't find anything along those lines. But that doesn't mean that people are totally myopic. I'm going to pretend they're myopic. It's interesting to think about how to build a dynamic version of the arguments that I'm going to use today, but that's for future work. There is a non-financial incentive I am going to incorporate into the model, which are the work requirements and sanctions. So essentially, you're going to get hassled more under Jobs First. They ask you to participate in these job training programs, and they ask you to participate in job search programs, and if they don't think that you're honestly trying to find a job, they can sanction you, they can kick you off, and they can keep harassing you, okay? And we're going to need to think about the possible incentive effects of that hassle. Okay, data come from MDRC's Job First public use files. I already talked about this a little bit. There's some technical details that not everybody needs to know. The main thing I want you to know is we're going to have two different measures of AU size. AU stands for assistance unit. That's the unit getting the transfer. The federal poverty line depends upon how many people are in your assistance unit. And we have an imperfect measure of that based upon survey data. But I can actually back out from the administrative grant amount what your AU size must be for the treatment group only. Okay, so sometimes I'm going to show you stuff from that administrative measure, which is of higher quality than the survey-based measure. Here's some descriptive stats from the experiment just to show you that randomization worked. There is a spurious difference in average pre-treatment earnings. We're going to adjust for that chance and balance. If you do a joint test, randomization appears to have worked. So it's not surprising that some things have stars on them. By chance, we're going to reweight the sample with propensity score reweighting to adjust for these chance imbalances, and that also slightly improves efficiency. Okay, so let's start off with a first test for whether there's any intensive margin response. So if you have the sharp null that all that's happening is that this program changes who works and who doesn't work, then all you're doing is you're shifting people from one origin, which is zero earnings, not working, into a positive amount, which means that you're just shifting a distribution to the right, okay? So if there's only an extensive margin response, there should be first order stochastic dominance relationship between the treatment group and the control group's earnings distributions. So I'm going to start with a first order stochastic dominance test. I'm also going to split my test by a group that had positive earnings pre-treatment and zero earnings pre-treatment. The idea being that the work disincentives are strongest for people who would have, in the absence of the reform, earned high amounts. Those are the people in the neighborhood of that notch who are induced to lower their earnings, okay? And the idea is that they're earning 7 quarters prior to treatment. I choose 7 because there's a so-called Ashenfelter's dip. People who are on welfare are people who have recently been having a hard time. So if you look 1 quarter prior to baseline random assignment, almost everybody has a 0. But 7 quarters prior to random assignment, some people don't have 0, okay? All right, so here's what we get. So first, this is the earnings distribution in the AFDC group and the Jobs First group. So what do we see immediately? And if you do a reweighted Kolmogorov-Smirnov test, obviously there is a treatment effect on the distribution. This is saying more people work, period, in Jobs First. That's why this thing starts out lower. There's fewer people at 0 earnings. And we see if you take the derivative of the CDF, you're going to see the density. So there's a lot of people who have positive density at low earnings levels in the JF group relative to the AFDC group. We're not seeing much go on in the neighborhood of the federal poverty line. So we've rescaled quarterly earnings relative to the federal poverty line. It says 3 times FPL because these are the federal poverty line is a monthly concept, and we only have quarterly earnings records here. Okay, if we split things by whether you were 0 earnings prior to random assignment or positive earnings prior to random assignment, what we see is that we can reject first order stochastic dominance in the high earning group, which is what you would expect if there was any kind of opt-in behavior with people responding to the notch by lowering their labor supply, and B, it is formally something that cannot happen if all the program did was move people from 0 to positive earnings levels. Okay, so we know there must be some sort of intensive margin response, but how to quantify it? And the answer is going to be, I'm going to have to use some economics and actually place some restrictions on this thing so there's a real model here. But before I do that, let me just show you some features of the data that suggest what needs to go into that model. So one thing, this is now using the better measure of AU size. One thing that any differentiable model is going to predict is that the earnings distribution ought to exhibit bunching in the neighborhood of the federal poverty line. And we don't see any bunching here. We also don't see any bunching even if I condition on being on assistance all 3 months of the quarter. Okay? So that suggests that we need a model where that can happen. Otherwise, don't build the model. It's immediately rejected. Okay? I'm going to add labor supply constraints that can accommodate that. The second thing we see is it looks like maybe things are not being enforced correctly. And because these people have earnings that are above the federal poverty line, yet they were able to receive benefits for all 3 months of the quarter. And we're going to rationalize that by building in underreporting behavior. There's a lot of evidence from similar experiments and going back into the 80s just from audit studies that people are underreporting their earnings to the welfare agency. And the earnings I'm using here are not the earnings that are reported to the welfare agency. They're the administrative UI earnings. Okay? So I want to have a model that satisfies these two minimal conditions so that it's not a stupid model. And so I'm going to build both of these features in eventually. Before I do that, I'm going to start with a stripped down warm-up model because this has to be the abridged version of this talk with only 40 minutes. Okay, so we're going to have a conventional static utility maximizing model. Women have utility over earnings and a consumption equivalent. Earnings lower utility because they require effort to generate. Many of you are used to models where hours lower utility, and that is the more fundamental way to do it. I don't observe hours. But I have put an I subscript on U. And so if, for a given person, if they face a constant wage, their effort and their earnings are assumed to be 1-to-1 here. Okay? And I will define the consumption equivalent in a minute. So this UI is going to be totally unrestricted other than these monotonicity restrictions and how it responds to its arguments. The policy rules are summarized by the function GIT of E, which gives you the transfer income you would get if you earned an amount E under policy regime T, which can either be AFDC or jobs first. Okay, D equals 1 if a woman participates in welfare and 0 otherwise. The consumption equivalent is going to incorporate pecuniary transfers and then a variety of psychic costs. So your consumption is your earnings minus a fixed cost of working mu I. Okay, going back at least to Kogan, there's reasons that we always want to have fixed costs of working. You don't want to go to the trouble of showing up to work just to earn $1 a quarter. If you work and are on welfare, so this D only turns on if you're on welfare, you get the transfer amount. You pay a stigma, fee I. We need stigma because we have to explain why some people who are eligible for this transfer don't take it up. Lots of people who are eligible for welfare do not receive benefits. And we also have a hassle cost, which you only face if you don't work and you are on welfare. Okay? And that's A to I T. And I'm going to assume that jobs first level of hassle is weakly greater than AFDC's. Okay? And so now, and note I've got I subscripts on all these psychic costs. So their distribution, their joint distribution in conjunction with the joint distribution of utility functions is completely unrestricted here. Okay, so the woman's problem is to maximize utility or choice variables, or whether to work on how much to earn and whether to participate in welfare or not, okay?
That's a question. You said earlier in the introduction that hassle was related to going to a job training program.
I misspoke when I said training. Job search program, yeah.
There still could be some possibility of like augmenting their wage or something. I'm just wondering if there's a productive component associated with it.
The program is not designed to have that productive component. The program is designed to get you off your ass now and employed. That's why it's called Jobs First. Jobs before human capital, in a sense. That's just human capital second. So what does the model do? It restricts how we compare our choices under AFDC with our choices under Jobs First. And these restrictions follow from simple revealed preference arguments. Essentially, you can only, essentially the reform made working on welfare more attractive. It potentially made not working on welfare less attractive because of the hassle. And it had no impact on the appeal of other choices like working off welfare. And since preferences are invariant to the regime, what the reform is going to do is going to induce women to choose, so it will not cause them to choose options made less attractive by the reform, nor to abandon options made more attractive by it. So let me just give you a visual rundown of what we can learn from simple consumer theory, okay? So let's start with people who wouldn't have worked under AFDC. Okay, so down here at point A prime, you've got somebody who would have not worked and been off welfare. How could they respond to this reform? One thing that they could do is they could suddenly go on welfare and work. But we wouldn't expect them to stay off welfare and change the amount they work, because they could have done that before the offer. And by revealed preference, they won't do things like that. They won't move to a point, some other point on this 45-degree line. How about somebody who would have started at point A? They would have been somebody who does not work and is on welfare. They could either stay at the same point under Jobs First, or they could start working a positive amount because we reduced their implicit tax rate, or they could be somebody who really doesn't like to work at all. But I'm hassling them now because they're not working. And so I hassle them off of welfare down to this point A prime. So when I used to be a Master's of Public Policy student, when welfare reform had just started, there were all these people in sociology and public policy that were very worried about people like this because they think they're people with work disabilities and they can't work, and the only way for them to respond is to go down here, and we worry about their consumption level. And then another thing that can happen is people from point A could be pushed all the way up here into working a lot. Why would that happen? Because I'm hassling them. It's true they could have chosen this point before under AFDC, but this point suddenly has become less attractive. And so they could leapfrog all the way up here. We could hassle them into working a lot if they're a high-skilled person who happens to be on welfare. Okay, how about people who would have worked at low earnings levels, by which I mean below the federal poverty line, under AFDC. So if you're someone who would have worked off welfare, it's possible that the reduced tax rate on welfare induces you to join welfare and continue to work. If you're somebody who would have worked on welfare anyway at point B, you're going to stay within this working region below the federal poverty line. Where exactly you're going to move is uncertain. You could work more or less depending upon whether income or substitution effects dominate. Okay, but you certainly won't choose to work off welfare up here because by revealed preference you could have done that under AFDC and you chose not to. Okay? Finally, there's the possibility of opt-in. People who would have worked off welfare above the federal poverty line when offered AFDC could choose to work on welfare under Jobs First. And indeed, we would expect if there's for many different preference schemes, we would expect a lot of them to bunch at the federal poverty line exactly when offered Jobs First. Okay, but clearly they can't choose to move down here or something because they could have done that before, okay? So revealed preference rules out lots of transitions. Those are all of our allowed responses. Here's what theory is ruled out. These are all the disallowed responses. There's tons of them, okay? And so we've learned something without making much in the way of functional form assumptions. I'm sneaking some stuff into the consumption equivalent, but I think relative to much of the literature, this is very unrestrictive. Okay, now I told you I have to build in some extra stuff to not have the model be immediately rejected by stylized features of the data. So I'm going to add now reporting decisions and constraints. So now women choose an amount to report to the welfare agency, ER, in addition to the amount that they actually earn, okay? And transfer income depends upon the amount that you report, okay? But you face an underreporting penalty. So now we've got this kappa I, which is its joint distribution with everything else, is again unrestricted. This is how much psychic cost. You can also think about this as the expected sanction you face if you get caught lying to the welfare agency about your earnings, because this could be also thought of as the cost of concealing a paycheck, a pay stub. Okay, so this is the amount you pay for reporting less than you actually earn, and you have a transfer amount that depends on how much you report. Okay, and to accommodate constraints, I'm going to do the minimal amount necessary to incorporate constraints non-parametrically. So each woman draws 2 earnings offers, O1 and O2, from a bivariate unrestricted distribution function, f of I. 2 draws is enough for an intensive margin response to reform to be present. And indeed, it nests the unconstrained model, because O1 and O2 might, just by chance, happen to correspond to what you would have chosen if unconstrained under AFDC and jobs first, respectively. Okay, so it nests it, but it's also possible that O1 and O2 are something totally different, which you would never want, and that they're the same thing, and that in particular, all this does is this just it provides an explanation for why people are not bunching exactly at the federal poverty line. I'm just shutting that down. Although in some generalizations of the model in the appendix, these constraints do other stuff. They sometimes open up possible transitions, but not in this basic model. Okay, so now the woman's problem is to choose an earnings level from between not working, which is 0, O1, and O2. Those are the options. They choose whether to participate in welfare or not, and they choose an amount of earnings to report to the welfare agency up to the amount that they actually report. Okay, so now some new things can happen. Okay, so now I have to plot the budget set in utility space for you. Okay, so the y-axis is the consumption equivalent, the x-axis is earnings, and you have the option to underreport under AFDC and jobs first. It's the same line because your implicit tax rate is 0 when you underreport. You report that you earn nothing or that you earn $2, and so it doesn't matter how much you actually earn. And that's why this green line here, which is the underreporting utility, has slope 1, okay? Because the tax rate is 0 on when you're underreporting on your actual earnings. Okay, so what can happen? There's 2 things that can happen now. One is that there could be a truthful reporting response to reform, okay? So in other words, you could have been a liar. You were on the green line, point A, under AFDC, because your utility curve looked like this. And under jobs first, you choose to become a truthful reporter because the tax rate on your earnings is 0 below the federal poverty line. So why bother lying? Another thing that could happen that's more nefarious is that you could be hassled into underreporting. Okay, so we've got 2 new allowable responses. Now I'm going to talk briefly about identification and try to get some results. Okay, so this model, because it's so flexible, it has no cross-sectional predictions for a single policy regime. There doesn't need to be bunching. There's nothing you can learn from any moment of the data about transition probabilities, or response probabilities rather, without policy variation. When you do have policy variation, what you've got are non-parametric restrictions on the pairing of responses across different regimes. What we're going to do is we're going to coarsen the data into regions over which we have clear predictions. So specifically, we've got, we're going to have E squiggle, which equals 0 if you don't work, 1 if you work but you earn less than the federal poverty line, and 2 if you earn above the federal poverty line. And that gives us a set of what I'm going to call states, and maybe that's not the best word, but that's the word I've got, so I'm going to use it, which are couplings of your earnings level with your welfare participation and reporting decision. So N means non-participation, R means I participate in welfare and I truthfully report my earnings to the welfare agency, U means I participate and I underreport. So the possible choices are 0 N, I don't work and I don't participate in welfare, I work but earn below the federal poverty line and don't participate in welfare, I earn above the federal poverty line, I don't participate in welfare, I don't work, I participate in welfare, I work but below the federal poverty line, I participate in welfare and I truthfully report my earnings, I work below the poverty line and I underreport my earnings, and I work above the federal poverty line and I underreport my earnings. I cannot truthfully report my earnings if I am working above the federal poverty line and remain on welfare because of the eligibility rules. Okay, I'm sorry that took so long to say. I'm going to use SA and SJ to denote the potential choices that a person possesses when exposed to AFDC and Jobs First, respectively. And what we show formally in the paper is that we have all these restrictions on what can happen. There's lots of pairings of choices under AFDC and Jobs First that are ruled out here. Now, we're interested in factoring the joint distribution of potential outcomes into a conditional distribution, and basically what we've got this experiment, so we can actually identify by random assignment the marginal probability of every choice when exposed to Jobs First and when exposed to AFDC. So we know the PJ vector and the PA vector. What we don't know is this matrix pi of the probability of making a given choice under Jobs First, given that you would make a different choice under AFDC. And that's what's going to concern us today, because that's one way of summarizing intensive and extensive margin responses. So we prove in the paper that the matrix looks like this. And of course, the empirical content here comes from all those 0 restrictions, which are just derived from revealed preference. Now, there's an unobserved state here. We integrated out. The matrix looks like this. Awesome. OK, so we've got, at the end of the day, the economics of this system boils down to 5 equations and 8 unknowns. That sounds bad. It turns out one of the pi's is point identified. The remaining 7 unknowns obey these 4 linear restrictions. These actually have a very intuitive interpretation. On the left-hand side is all stuff that we can see. It's differences in marginal probabilities, right? Those are like net flows. And the right-hand side is the gross flows that generated those net flows. Okay? And so the economics is telling you this is how you rationalize these differences in marginal probabilities as a function of flow probabilities, okay? But that we can't see. Even though this model is only partially identified, it's what I've heard Andy Cheshire call over-partially identified, in the sense that it's still refutable. There are these inequality restrictions that could be rejected. The point estimates are actually going to satisfy these restrictions. OK, so I can take this system. I can get bounds on the pi's by setting this up as a linear programming problem. We just solved the linear programming problem by hand, which sucks. If you ever try to do that, you have to enumerate a lot of possibilities. We get analytical solutions for the upper and lower bounds on each response probability. We're going to use 2 approaches to inference. One is we're going to just pretend that whichever solution in here binds in the sample is the one that binds in the population, and then apply Immens and Mansky. Then at the opposite extreme, we're going to do a conservative inference that assumes the worst case scenario, that they're all the same, and then do a bootstrap procedure to do inference. It's kind of a degenerate version of Chernozikov, Lee, and Rosen. The conservative is going to turn out not to be that much different than the naive. OK, so here are the experimental impacts on the probabilities of occupying each state. Let me just skip. I'm running out of time. I'm going to skip to the meat of the results. OK, so here's one result, which is that this is the one point identified margin that the program induced 38% of the people who would have been working off welfare to work on welfare. Okay, and there are confidence intervals up here corresponding to that statement. Okay, we do find a significant opt-in effect. So this corresponds to an intensive margin response. There are at least 28% of the women who would have worked off welfare at high earnings levels reduced their earnings in order to get on welfare. and receive benefits. Okay, so that's a pretty big lower bound for an opt-in effect that survives adjusting for sampling uncertainty in the bounds, regardless of which. I mean, there's only one lower bound, so it's not surprising that the deterministic and the conservative are the same for the lower bound. It's the upper bounds where it's different. Okay, we find the point estimate of the bounds suggests that at least 6% of the women who would have been off welfare and not working were induced to go on welfare at low earnings levels. So that would be an extensive margin response, but that doesn't survive adjustment for uncertainty in the sample bounds. We also find at least a very small window, but a significant window on the women who would have been on welfare and not working who were induced to go on welfare at high earnings, meaning we find that the program hassled some people into underreporting. It's not many, but there were some. And so you actually need this to rationalize the reduced form experimental impacts. So underreporting behavior does seem to be important. There's a lot of stuff that we can't get informative lower bounds on, but we have somewhat informative upper bounds. And then it's interesting that when models aren't point identified, that sometimes linear bounds on linear combinations of parameters are much tighter than bounds on the parameters themselves, even before you account for sampling uncertainty. So it's actually the fraction of women who would have not worked who were induced to work is point identified. And that kind of makes sense because it's monotone. It can only cause you to work. It can't cause you to not work at all. This is not point identified, however. The fraction of women who would have not been on welfare who were induced to take up welfare is somewhere between 0.23 and 0.44. I think that's pretty interesting. And you can get a pretty informative upper bound on the people that I told you that my old professors at Michigan when I was getting a master's degree were worried about. How many people were kind of hassled off of welfare into not being on welfare? At most 17%. Okay, so I'm finding substantial intensive and extensive margin responses to reform. We needed underreporting behavior for the model not to be rejected. We didn't find any bunching, but nevertheless, there was a big impact, so that should be a cautionary note on people to think you could throw away the whole data set aside from the kinks. You could easily apply this sort of argument to lots of other settings where you don't have a true randomized experiment, but you have a quasi-experiment. There is a structural model, but I'm not point identifying the structural. The pies are functionals of the structure. The structure is the joint distribution of utility functions and psychic costs. So it's difficult to extrapolate with a model like this. One way you could do it is if you had lots of experiments that manipulated different sorts of policy parameters, then you could just do a statistical curve fitting exercise, fit the pies to the policy parameters and extrapolate out. I'm unlikely to have data like that in my lifetime, so maybe a better approach going forward is to consider what else you can get if you are willing to make, say, semi-parametric modeling restrictions. Then you actually have scalar parameters that you can go after, and maybe you can use those to do counterfactuals. But I think of this as a proof of concept paper, and it's interesting that we were able to learn some stuff that was substantively important without assuming very much. Thank you.
Enjoyable paper. I heard it before, and it's becoming clearer. But I may reveal that I don't get all the bits of it. But let me go. It's a lot of fun to read, and there's a lot going on here. So let me talk about the aspects of KT. So I'm going to look at, if I have time, which I won't, but there are 4 kind of aspects I thought were fun to go through. Not all of which, I should add, Pat has emphasized in his talk today. But I wanted to think about the model and how it relates to the standard models that many of us, certainly me, have worked on. Think a little bit about dynamics, as I think if you talk to people about why these programs were introduced, it's true they wanted to get people off welfare and into work. There was a kind of side of things that said, and this would be good for them in the long run. And let's think about that, because that can clearly have an impact here. There's reporting many of the issues that were raised there, and I want to emphasize a couple of issues around the size of treatment, actually. And then, if I've got time, think a bit more about where we could go with the reveal preference work to add more. I've got no particular objection to what. So what Katie did. It's a nice creative paper. So the aim is to use this randomized welfare experiment and RP restrictions to recover some structural labor supply responses. Great aim. And one could think about doing this. In the consumer world, people think typically about going across markets where you have a set of prices in one market, a set of prices in another market. You've got a distribution of people facing those prices. But the distribution of unobservables is unaffected by the market up to observables. And so that's very like the way you ended, in fact. And I think that's right. But you get some advantages here. This is a nice welfare experiment. The baseline is a single, as far as I could tell, the baseline was a set of single mothers on welfare, as in the self-sufficiency project. So they're very low earnings people, maybe no earnings people 3 years before or sometime before. You don't really use that. I think that could be quite useful. The SSP has used it a lot. But the notches are great, of course, for us. They're almost, as far as I can tell, probably one of the worst designs in public finance, but we like that kind of thing. And you're going to exploit the independence, of course, that comes from randomization lots and use the RP inequalities to test. Amazingly, even with this, you have some testable restrictions. I mean, typically what happens is you have a set of testable restrictions and that allows you to bound some predictions. And we'll come back to that. There are very limited measurements. That's the first point. Relative to what I usually think of when I'm doing a labor supply piece of work, it's relatively little you know. You know about on welfare, you know on JF or AFDC, you know monthly eligibility, and you get a broad measure of quarterly earnings from the admin data. The restrictions then remain informative here, but they're insufficient really to do what we would like to do, and that is to do counterfactuals of new budget constraints. There is something in it. They have weak predictions. For example, you can say whether or not the extensive and intensive margins are zero or not, and that's pretty useful, as you said. I'm thinking about RP analysis, as many people have here. One of the key things that give you a lot of power is when budget lines cross. In fact, in the standard model, that's what you have, because you just got linear constraints. And what I'll argue here is you're really throwing all that away by the way you're thinking about the problem or the data you have. And you can't use those at all. In fact, when you think of nonlinear budget constraints and two goods, which you've got here, consumption and leisure, basically, or consumption and effort, you know, nonlinear budget sets are like a dream for us, really. They've not just got potential crossings, they've got kinks, and if we're lucky enough, notches. And in fact, Chuck's paper in the QE goes through a lot of the way to think about exploiting those. Observing earnings, that's the first issue I'll take up with you. You use earnings, you put earnings in the utility function. I'm not a great fan of that. It turns out, of course, they're smart, the authors here, and they don't really use, they use it as a kind of summary, because when it comes to it, the course measure that they have, it means that they get round any problem of having earnings in utility, actually. But it means that they know nothing about where they're placed on the intensive margin apart from in these regions. And typically in a labor supply model, you know where people start, you know their hours or effort, and that's going to be quite important. And to make any improvement, you have to, I think you've got to go in that direction, and we'll talk about it. But generally, evidence of these two entry and opt-in offence, really nice, very important for welfare design. The figure tells you everything. You know, if you were a die-hard structural labour supply guy with all the parametric model, all you would need is either one of these in effect, and you just go for broke on one of these budget constraints. You would bring in something else that you're not using. So here, We have earnings here. Of course, typically we'd have hours or effort if we could measure it. And we'd have, by varying the wage, a huge variation in budget constraints, which would then effectively cross. And we could do a lot of non-parametric identification if we have independence of unobservables. And if you look at the Bloomquist-Newey paper, that's effectively what they're doing. They're willing to get identification within, non-parametric identification within a regime, actually, by using wage variation and independence. And that gives them a lot. And of course, that's one direction you could go. There's no need to be parametric there. They have a nice result here. What you're doing is assuming, you're not assuming that I can unpick hours here. And so that's going to be very important in a minute, as you'll see. And you're putting sufficient heterogeneity and stuff on here that there's nothing that really is learnt from a single constraint, even though you have a lot of people, a large sample on that constraint. You're making assumptions that doesn't allow you to learn anything from it. All you can learn about is the comparison across these two markets or two more. So let me think a little bit about the first issue, the standard labor supply model. Typically we put hours in consumption, we have some observables, and we have some typically very limited amount of heterogeneity. And we have a budget constraint, consumption, a tax function, an earnings, which is equal to wages times hours of work, a log wage equation, a lot of stuff. You didn't see any of that here at all. So what's going on? And in fact, what KT do is they're going to model utility as a function of earnings and consumption, just a straight constraint, and everything's indexed by I, so it can be completely general, which is terrific. They really, they've got this very coarse measure of earnings in these three, either zero below the federal poverty line or above it, and welfare participation. That's about all they're going to use here. And they're going to, so that's almost taking out everything that you have in the standard model. One key point here is that with earnings, if you think about, why don't we like earnings in the utility function? Actually, what you do is completely, you don't need to worry about this, it turns out, if you look at it. So I would suggest that you kind of relax this a little bit, because it looks a bit odd to have earnings. For example, 2 earnings points can be made up of, part-time work, high wages, full-time work with low wages. You can't order those. There's no weak ordering over earnings. And it doesn't really matter. You can weaken that and look at effort and things, but the key point is that this relates to Bernard's question. You can't order across different earnings points, so you can't use all that information that we would usually use in the top model in this one, and in fact you don't. You throw away all that information. If you had it, you could, without unquestionably, get tighter bounds, I think, and learn a lot more about the counterfactual. But when I was reading this again, I thought, oh my God, what's going on here? You're putting earnings in the utility function, throwing away everything that we normally use. But you play it to your advantage incredibly, because you allow, then you say, well, I can put all these things in and just get some basic revealed preference inequalities or conditions that you said. I just list the stuff. You don't specify a tax function, just a position and notch. You have this nice relationship between reported and actual earnings. You use randomization. But you're missing quite a lot, I think, within the intervals, I would argue. And I think if you look at it, what typically identifies gives you more power, more identification, even in the non-parametric form, in a standard model would be going within and getting those variations. But that's it's interesting contrast with the standard consumer model, which has no notches or kinks, and you get nothing here. And so so the standard AFRIAC type crossing ideas and those are not going to work, not going to be particularly useful here. It's kind of nice. The two-offer model, I'm just picking on things that worried me a little bit. So you said so the way I typically think about the two-offer model nesting the standard model is that if the number of offers are not 2 but go to infinity, then you get the standard model. And I didn't quite get your point there, but I can see what you're saying, but I still think that, that a two-offer model is incredibly restrictive. It's the kind of far extreme from the standard model because you're only getting two choices and no choice. Of course, you're not going, if you think about this, and I've thought about it a lot, have a paper with Guy on how you'd identify a two-offer model in a structural model, and you need variation across dominated segments. You're almost doing that, but you're not interested, in fact, in identifying the offer distribution. You're just using it to explain the lack of bunching, but I think it causes some potential difficulties because in a two-offer model, for example, there's an increased incentive to underreport and stay on jobs first if the next period you may get an offer that's that puts you on jobs first. So you might get some state dependence coming in here. Also, the point about talking about ranking offers, there's no, I couldn't see any way that I could get any weak ordering across offers, but you talk about it as if there is, because I don't know what the level of effort relative to the wage or the level of hours relative to the wage. So earnings 1 being greater than earnings 2 doesn't tell me about the how I should weekly order those in utility space. It's the same point again. Okay, I've lost time. How can this be? I'm only on point 2. This is terrible. No experience, so let me forget about the other dynamics thing, wage experience. So this is an area where I think you're on strong grounds, and I think you may mention it, but it is pretty remarkable how the evidence for strong complementarity is coming out everywhere. And for these low-skill mothers, the idea that wage progression was going to be much, it's very unlikely. I'd have liked to have seen something, because you've got more or less the same data as in the Canadian SSP, for example. And in that data, you know, here's a plot of it. There's the treatments and the controls. The thing finishes where they come together. At the point where they come, the program is over, by the way. This is a similar incentive program with a time limit. There's no long-term effect on the earnings or the wages of the two groups. And that's very powerful, and I think helps you a lot in this. Yeah. A couple of small points as I'm on 0. The administration and welfare. I worry more about measurement error here because these are both authorities. One's an administrative one, the other's a welfare authority. Are they really allowing such deviations? That would be difficult, certainly in the UK. There'll be more tying up between the UI authority and the welfare agency than you're allowing there. That's food stamps. The point here is you point out that if I bring in food stamps, it actually doesn't change anything. It doesn't kind of qualitatively, but it does change the size of the treatment. So another thing I was looking for in the paper, but I didn't get, in that, what do we think the treatments are in this sample? So if we're looking for something that's useful, kind of pushing a little bit further in welfare design, you don't only want to know the response, you want to know how big the treatment was that they're responding to. And I didn't really see that. So I'd like to know, what do you think the distribution of these treatments are? Because what happens if they are on food stamps is that they get an increased incentive to be in the, it kind of amplifies the effect, as you said. So if we're not using the budget constraint at all here in a sense, and that's something I didn't look. I'll talk about. Yeah, I'm more or less out of point. Just to finish with a couple of things that you could do, just on the literature which you don't refer to. There's a lot going on, obviously, in Chuck's paper that you do refer to, and you could go more down those lines. But you would have to say something, I think, on how you're going on the intensive margin on earnings. If you go down the Bloomquist-Newey route, which is kind of popular, that's one kind of new paper, what they're doing there is really using the continuous margin of hours, and they're using the result that if you've got non-separable independent heterogeneity of quite high dimension, you still will get a Slutsky condition on the linear segments, which then allows you to put probabilities on the corner, on the kinks, and you can begin to get much more, stronger identification and more predictive power. The other way to go is to put some, like I do with Dennis and Rosa, is to put some rank invariance or something on the heterogeneity, so obviously that's a strong assumption, but then what it allows you to do is to, as you look across your two experiments, you can say the guy who was there is now here in that one, and that really helps pin things down. You may not like it, but of course, in a standard parametric model, that's what people are doing. In very recent work, and there are other people doing this, there's a huge amount of work going on now trying to relax that and try and identify the distribution of heterogeneity in more general conditions than just using rank invariance. And there's work I'm doing and others on that. But it's a really fun paper. I love the idea. I think you know, it really nails a couple of effects here. And the one thing I would say is that, you spend a lot of time with this earnings in the utility function. In fact, you really never use that idea. You could equally well just have effort, because at the kinks and the notch, all you need is earnings, even in a model which had unobservable effort in the utility function. And so you don't really need to specify it that way. Sorry, I'm way out of time.